All right, we're going to do lesson 54, solving simultaneous equations by substitution. I feel like we didn't get to do that enough in our class today, so I thought that I would do a few more examples in case you didn't understand it. So we have, look at example 1. We have here, trying to get a cursor that you can see. Hold on a second, this is all new to me. Okay. We have two equations, linear equations, and we are trying to find the solution, the x and y value, the ordered pair that will satisfy both this equation and this equation. And we talked about how if we were to graph these two lines, the point where they intersect would be the solution to both of these problems. So there's a couple different ways to solve systems of equations, and the way we're going to do, the way we did today was by substitution. Later we're going to learn to do it by elimination. So this is the substitution method. They start out easy. You'll see the first equation is 2x minus y equals 1, but the second one is x equals minus 3y plus 11. First thing you have to do to solve them by substitution is get a variable by itself. And on all these problems, they have already gotten the variable by itself. So x is by itself, and x equals minus 3y plus 11. So what we're going to do to solve these is to take what x equals minus 3y plus 11 right here, and we're going to put that, all of that in where the x is right here. So what that's going to look like is 2 times minus 3y, plus 11 minus y equals 1. I should have made these apparently a different color. Oops. I can't seem to make this turn white. Alright, so you can see what I did. I just have here the minus 3y plus 11 went in up here where this x is. So now I have 2. Instead of an x, I put what x is equal to, minus 3x plus 11. Now it's an equation with one equation with one variable, so we can solve it. So we just distribute minus 6y plus 11 minus y equals 1, and we combine our like terms, minus 7y plus 11 equals 1, minus 7y, subtract 11 from both sides, equals minus 10. And it looks like we are going to get a fraction, but so I must have done something wrong. Oh, look at that. I forgot to distribute. That is a common problem that you might run into. It should be 22 right here. So we're going to subtract and we're going to get minus 21. Then divide both sides by 7 and we get y equals 3. I doubt if you're going to get any fractions because they want to teach you the process and not have you be messed up with fractions. So now we have this answer right here for y, but we need an ordered pair, so we need to figure out what x is. So we have to take what y equals and go back up to this spot and put the value back in for y, and that will give us x. So let's just finish this one up. So we have x equals minus 3y plus 11. Now I'm going to substitute in, so we get x equals minus 3, and we have here that y is equal to 3. So we're going to put in there 3. Plus 11. So we're going to get x equals 2. So our ordered pair is, I'm going to write it, is is 2, 2, and y is 3. So you would write your answer as an ordered pair. Let's try another one. Look at example 2. This time, you look at 2x plus 3y equals minus 13, y equals x minus 6. So we have to get a variable by itself, and it's already done for us. So we take what y equals, x minus 6, and we're going to put it in for the y. Because y equals, we're going to replace this y with x minus 6. So let's do some substitution here. So we get 2x, and remember we're going to replace that y, plus 3. Instead of putting the y, we're going to put what y is equal to, which is x minus 6. That's right there, that one right there. Equals minus 13, and we solve it quickly, 2x plus 3x minus 18. This time I remember to distribute, equals minus 13. 5x equals 5. If I add 18 to both sides right here, x equals 1. And then we have to go back and put that up here where the y is. So we have the equation y equals x minus 6. That's above here. We're going to put in, for the x, we're going to put in the 1. Y equals 1 minus 6. Y equals minus 5. You can always check to see if they're right by substituting them back into the equations for the x and y. And then you would write your order pair, x first, 1 minus 5. Let's quickly do one more. This one's a little bit different, so I thought we would try it. This one, we have x equals y. So we can either substitute where the x is, we can put the y, or where the y is, we can put the x. So I'm just going to say x equals y, so I'm going to put the y in for the x. That way we only have one variable and one equation. This one looks pretty easy. So we're going to get 2y plus 3y equals 5. So for this, where this x was, I put the y, because y equals x. And then we can solve it. We get 5y equals 5, y equals 1. And then we have to go back, and we know that x equals y, so we'd say x also equals 1. And finally, we write our ordered pair. It would be 1, 1. It doesn't matter the order because they're both the same. So in case you didn't get that in class, this should help clear up any problems that you had. And that's it.